Students, let's start with the new article. The statement is, if two complex numbers are equal, then their real and imaginary parts are separately equal. Let us suppose two complex numbers a plus iota b and c plus iota d, such that the both complex numbers are equal. On taking this complex number to the other side with the negative sign, we get the expression equals to 0. We have to solve the real part with real and the imaginary part with imaginary, as a minus c will be solved together and iota b minus iota d will solve together. Taking iota common from this bracket, we get the expression equals to 0. We know that the complex number can compare with the another complex number only. So we will convert this number into complex number by making the standard form as 0 plus iota 0. On comparing the real part with real and imaginary part with imaginary, we get the two expressions as a minus c is equals to 0 and b minus d is equals to 0. That means a is equals to c and b equals to d. This proves that the imaginary part is equals to imaginary part of the both complex number and the real part are equal in both the complex numbers. So the two complex numbers are equal only if both have real part equal and both have imaginary part equal. Our next article is, sum of two complex number is a complex number. Let's suppose z1 and z2 are two complex numbers defined as a plus iota b and c plus iota d. Adding the both z1 plus z2, we will find a plus iota b in addition with c plus iota d. As we know, the real part of complex number is simplified with real and imaginary with imaginary. So a will be simplified with c and iota b with iota d as a plus c plus iota times, because iota comes with b and d both, so I am taking it out as common, b plus d, which is the standard form of a complex number. So the result is, if we add two complex numbers, then the result is another complex number. Additive property. Let us suppose z1, z2 and z3 are the three complex numbers. The first property, associative property, says if we add z2 and z3 and then add it to z1, or we add z1 and z2 and then z3 is added, the result remains unchanged. Second property, commutative property. It says if we add z2 in z1 or z1 in z2, the result remains same. The third property, additive identity. Let's a plus iota b is any number in complex. Then on adding a plus iota b with 0 means we have to change this in the standard form so that we can add it in the complex number, because only two complex number can be simplified. We cannot add a complex number with the real number. So we will change it into the standard form as 0 plus iota 0. On adding, we get a plus 0, iota comes out and b plus 0. On simplification, we get a plus iota b. Again with 0, we are adding a plus iota b in 0. Again we change in the standard form. Applying the addition of the two complex number, we get the same result, a plus iota b. That means if we add 0 in the complex number or complex number in the 0, we get the same result, a plus iota b. That means this 0 plus iota 0 is the identity element in complex numbers. Next is additive inverse. Let z is equals to a plus iota b is any complex number. If we add negative of the same complex number in the original complex number, as a plus iota b is added with the negative sign minus a minus iota b, on simplification we get 0 plus iota 0. Or when we add the original number in the negative of itself, then we get the same result. That means if we are adding the negative of a number into the original or original number into its negative, we get the same result 0 plus iota 0. Then minus of z is called the additive inverse of the given complex number z. Next topic is product of two complex numbers. Let z1 and z2 are two complex numbers defined as z1 is equals to a plus iota b and z2 is c plus iota d. Now we will find the product of two. Then we multiply these two factors with same method as we have done in the lower classes. In the multiplication of two factors, we get AC plus iota times AD plus iota times BC plus iota square BD. We know the value of iota square is -1, so I am using it here, and this addition sign changes into negative. On simplification, we get AC plus iota times AD plus iota times BC minus BD. Now you can see that AC and BD are both without iota terms. So we will collect them together in a bracket. They will make the real part of the complex number, and the term with iota sign will come together in a bracket, and I am taking iota common as it is common in both the two terms. Now this is the standard form of complex number. So the result is, if we multiply two complex number, the result is another complex number. Now the division of two complex numbers. Let z1 and z2 are the two complex numbers such that z1 is x1 plus iota y1 and z2 is x2 plus iota y2. And the division is valid. That means denominator is not 0. So to solve this expression, we have to use rationalization. We will rationalize the expression using the denominator. Here the sign before iota is addition, so we will reverse it and use it here for rationalization, as we will use x2 minus iota y2 above and below. After multiplication of two factors as we have done above, we will get the result as this. I have separated out the real part and the imaginary part. In the denominator, there comes an identity we have done in the lower classes, that is a square minus b square is equal to a minus b, a plus b. Here x2 plays a role of a plus iota y2 plays a role of b. That means this is our a and this is our b, and this is again our a and this is b. So we get a plus b and a minus b. Using the same identity, we can find this expression. In this expression, we are getting iota square, so we replace this iota square with -1, as we know it is the value of iota square. So the negative sign becomes positive in both sides, in both the factors, and this is our required result.